Math is clean, math's easy when you're doing math with Miss Lee.
Welcome to my lesson on graphing a rational function that has an oblique asymptote. In this lesson, I'll walk you through graphing the rational function f of x equals x squared plus x plus 3 over x minus 1, which is problem number 7 on page 7 of your packet for section 2.7. Normally, I'd start by factoring the numerator and denominator, but neither is factorable in this case. To find the domain, I need to find the discontinuities. To find the discontinuities, write an equation stating that the denominator does not equal 0, and solve for x. Here, the graph will have a discontinuity at x equals 1. So my domain consists of all real numbers except 1. To find intercepts, substitute 0 for the variable you're not finding. So for x-intercepts, substitute 0 for y and solve for x. When I substitute 0 for y, the denominator would cancel out after cross-multiplying, so I'm not even bothering to write it. Since I already know x squared plus x plus 3 is not factorable, I can try to use the quadratic formula to solve. This results in imaginary solutions, so the graph has no x-intercepts. Substituting 0 for x, I find that the y-intercept is negative 3. Since the fraction does not reduce, there's no possibility of having a hole in the graph. The x minus 1 in the denominator creates a vertical asymptote because it causes the rational function to be undefined at x equals 1. To find the horizontal asymptote, compare the degree of the numerator and the denominator. Because the degree of the numerator is greater here, this graph will not have a horizontal asymptote. It will have an oblique asymptote instead. To find the equation of the oblique asymptote, divide the numerator by the denominator. Since the denominator here is x minus 1, I can use synthetic division. The non-remainder part of the quotient is my oblique asymptote. That makes our oblique asymptote y equals x plus 2. To graph, I'll first draw dashed lines to represent each of the asymptotes. So I have a vertical line at x equals 1, and a diagonal line with slope up 1 over 1 that has a y-intercept of 2. Then I'll graph a point for the y-intercept at negative 3 on the y-axis. So now, since I know a point on the left side of my vertical asymptote, I'll graph that section first. I know the graph has no x-intercepts, so it must travel downwards infinitely on this side of the vertical asymptote. Out to the left, it has to follow the oblique asymptote. To the right of the vertical asymptote, I don't know the location of any points yet. I'll choose 2 to plug in for x to find a point over there. That gives me the point 2, 9. So I'll graph that. And then I'll make that part of the graph follow the vertical asymptote upward to avoid creating an x-intercept, and it will follow the oblique asymptote out to the side.